Today we're going to take those oxidation numbers that we learned about the last time and learn how to now analyze a redox reaction with them. He gives you a memory tip to help you remember the difference between oxidation and reduction. And he uses the Leo says grr phrase to help you remember the difference between the two. If it loses electrons, it's oxidation, which is where Leo comes from. Lose electrons, oxidation. And then if it gains electrons, it's reduction. So there's the grr part, gain electrons, reduction. The other way that I use to remember this is that if you've got reduction taking place, you actually have a reduction in charge. So if you've gained electrons, the charge becomes more negative, and so that has actually reduced the charge or reduced the oxidation number on it. So we're going to look at several different reactions here so that we can analyze these and figure out what's being oxidized, what's being reduced, and then what agents are actually causing that in this particular reaction. Okay, so if I've got copper plus silver oxide yields copper 2 oxide plus silver. The first thing you always have to do is to assign oxidation numbers to each element in the reaction. You'll remember the rules that you learned in the very first section talked about how an element by itself has an oxidation number of 0. So that means that the copper is going to be 0 here, and the silver over on this side is going to be 0 because they are elements that are by themselves. The oxygen, we learned, always has an oxidation number of a -2. And so here, since there are 2 silvers, and since everything has to add up to 0, each silver is going to have a +1. On the other side, the copper oxide, again, the oxygen has an oxidation number of -2, and the copper has an oxidation number of a +2, so that it will add up to 0. So now what I need to do is I need to look at the elements that are present in the reaction and determine what's actually happened to them. You'll notice that the copper went from a 0, oxidation number of 0 on this side, to a +2 on this side. So that meant that the charge went up, which meant it lost electrons. So that means that the copper was actually oxidized. The silver went from a +1 down to a 0. It had a reduction in charge because it gained electrons. So the silver was actually reduced. Now, here's a trick to make sure that you haven't made a silly mistake someplace. Anytime that you have a redox reaction, something has to be reduced and something has to be oxidized. And if you don't have one of each, then that means you've made a mistake, because you can't have one without the other. They have to go hand in hand, because this, which is going to be gaining electrons, has to get them from someplace, and so that means it had to get these electrons from this copper, which had been oxidized. Okay, so what was oxidized is classified as the reducing agent. After all, the silver wouldn't be reduced if the copper weren't here to provide the electrons for it. And so therefore, the Ag2O is considered the oxidizing agent. Notice the discrepancy, or not discrepancy, but notice the difference here. The silver was actually reduced because it's the element that changed its oxidation number, but the silver oxide as a whole is considered the oxidizing agent. So you want to make sure that you differentiate between those two. All right, let's look at the next one here. Cl2, the chlorine is not combined with any other elements, so it's going to have an oxidation state of 0, and that's going to be the same thing over here for the iodine. It's going to have an oxidation state of 0 also. So when I look at this, I have Ki. Well, this is a 7A element, usually has a -1 charge. The potassium is going to have a +1. And then over here, the KCl, the chlorine will have a -1, and the potassium will have a +1. Okay, so what's happened here? Well, the chlorine went from a 0 to a -1. The charge was reduced, so that means it gained electrons. So the chlorine was reduced, which means that it is the oxidizing agent. In this compound, the potassium stayed the same on both sides, so it wasn't changed, but the iodine went from a -1 here to a 0 here. Its charge actually went up, which means it lost electrons. So the iodine was oxidized, and so that means that the Ki is the reducing agent. Okay? One more example. NaCl plus AgF yields NaF plus AgCl. So once again, we need to go in, we need to assign oxidation numbers. Group 7A, the chlorine normally has a -1. Sodium's going to be +1. Fluorine, we know, always has a -1 charge. So the silver will be +1. Over on the other side, fluorine again is going to have a -1, which means the sodium has a +1. And then AgCl, chlorine has a -1, silver has a +1. Okay? Well, when I look at this, the sodium didn't change. The chlorine's -1 on both sides. The silver didn't change. It's +1 on both sides. The fluorine didn't change. It's -1 on both sides. So while this is a reaction, this is not a redox reaction. So there's nothing else to classify in this particular reaction. Again, as you're going through these and doing your homework today, make sure that you have something that's reduced and something that's oxidized. If you only have one or the other, you've made a mistake someplace, so you'll be able to go back and check your work that way.